In today's video, we will join RV19 and a special Renault Golette 4x4 R2087. As we will see, this restoration project is intended to be an exercise in mechanical revival and historical preservation. Spanning over 100 hours, it encompassed a complete overhaul of the engine, bodywork, and electrical systems. The Golette, a French military and utility vehicle born in the post-World War I era, served the nation's army and public services throughout the 1950s and 60s. Its reputation for durability, simplicity, and adaptability made it a staple in rugged conditions. However, one cannot proceed with mechanical restoration without first addressing the state of the bodywork. The body, after decades of use and exposure, was covered in oxidized paint, layers of dirt, and surface rust. Stripping the old paint is indispensable before moving on to body filler, welding, or primer applications. Old paint often conceals corrosion, micro cracks, or structural deformities that would otherwise compromise its integrity once restored. Once this is done, it is time to tackle its original Renault Type 6 to 71 gasoline engine. Before, some of the old parts were removed in order to address them later, which, as we will see, will represent a challenge. The 671-4 HS gasoline engine, having suffered decades of wear and corrosion, exhibited severe liner degradation. This is common in iron block engines left unused or exposed to humidity. Also, another focus was on the rear portion of the truck, which had been exposed to decades of grime, moisture, and oxidation. The entire rear box structure, often bolted but sometimes welded or rust-frozen in place, was separated from the frame. This was not a simple lift. Most of the bolts were seized, and in many cases had to be cut or ground out using portable power tools. As the rear section was lifted, it revealed the true extent of corrosion underneath, especially around the mounting points. Once removed during disassembly, each hub was first thoroughly degreased to eliminate the heavy accumulation of old lubricant. This preliminary cleaning was performed manually with brushes and solvents before proceeding to a deeper mechanical stripping. Each axle was pressure cleaned and manually scrubbed to reveal the metal surfaces beneath. From here, the differentials were carefully opened, revealing the internal gearing. The wear patterns on the ring and pinion gears were analyzed using a gear marking compound to ensure proper meshing. After the full restoration of both axles, the process of mounting them back onto the truck required careful handling. Restorers must resort to cutting their own gaskets from sheets of cork, nitrile rubber, or composite fiber. In some cases, custom O-rings or turned brass bushings must be fabricated to meet the dimensional requirements of worn housings. Furthermore, tolerances in the R2087 era were generous but inconsistent. The rear axle, which bears the significant weight of the cargo platform, managing drive torque from the transfer case, was tackled first. To mount the axle, the leaf springs were first secured to the truck's rear chassis frame rails using robust spring hangers. The axle was then rolled under the springs using a floor jack and maneuvered into position. Once in place beneath the springs, U-bolts and spring plates were used to clamp the axle solidly to the springs. These U-bolts are essential, as they not only secure the axle to the truck, but also ensure the correct alignment of the suspension system. This stage is not just about assembling parts, as it reflects adherence to best practices in mechanical restoration. It's the foundation for safety, reliability, and the authentic mechanical feel that defines classic military and utility trucks. For the engine, the original one, a 670-ohm 4HS gasoline engine, is a robust inline-4 unit. The disassembly began with a careful extraction of the engine from the frame, followed by a meticulous teardown. The cylinder liners, deeply pitted and rusted, were replaced with new wet sleeves. Unlike dry liners, wet sleeves are in direct contact with coolant, allowing superior thermal conductivity. This design choice is essential in utility vehicles subjected to varied and demanding environments. To guarantee their proper seating and seal, the block's liner recesses were cleaned and deburred before insertion. Remarkably, the pistons themselves were in reusable condition, thanks to protective grease that had prevented oxidation. Each piston was cleaned, visually inspected, and checked with micrometers and ring groove gauges to ensure dimensional conformity. They were then matched with new piston rings, and the ring end gap was measured with feeler gauges. Maintaining this gap between 0.15 and 0.25 mm was crucial. If too tight, the rings risk expanding and seizing, while if too loose, compression and oil control would suffer. The connecting rod bearings were assessed using plastigage, a soft measuring filament that flattens to indicate clearance. Ideal readings at 0.05 mm meant the crank journals were still within spec and machining was unnecessary. Before, the paint and rust were stripped from the cabin and the full extent of structural decay became visible. Rather than relying on modern prefabricated panels, which often lack the authentic profiles of vintage French utility vehicles, every patch was shaped and formed in-house, echoing traditional coach building methods. Working with minimalist but essential tools, the restorer reconstituted each segment. Flat sheet steel of appropriate gauge was cut to rough dimensions and gradually coaxed into complex compound curves. These curves were not just aesthetic, but functional, designed to manage airflow, resist flexing, and shed water properly. The challenge here lay not only in reshaping the steel, but in preserving the factory panel line aesthetics. Areas like the fender lips and lower door corners, notorious rust traps, had to be replaced in sections. Once the structural metalwork had been meticulously completed, he focused on restoring the surface evenness of the panels. While the metal shaping and welding were precise, the handmade nature of the work inevitably left behind micro imperfections. To refine the aesthetic finish and prepare the bodywork for primer and paint, the application of automotive body filler. While the earlier zinc-rich phosphating primer served as a chemical barrier against corrosion and ensured excellent adhesion, the next layer, a surfacer primer, was essential for creating the perfectly uniform canvas required before the final painting. This filler primer, typically a high-build formulation, was chosen for its ability to smooth out minute surface inconsistencies. Once cured, the entire surface was block sanded dry, often using long sanding blocks and guide coat spray to reveal any high area. The individual behind this R2087 restoration brings precisely that level of expertise, with a deep understanding of mechanical systems gained through both formal training and years of hands-on practice. They are capable not only of restoring what exists, but of re-engineering missing or incompatible elements with authentic fidelity. As we are witnessing, this kind of work goes far beyond simply turning wrenches. It involves reading the wear patterns on bushings to infer misalignment. Also, it may include reverse engineering a broken throttle linkage by referencing shadow marks on the firewall. The restorer must also fabricate tools on the fly, such as pullers, supports, and form jigs, when none exist commercially. Then, the chassis frame was rolled into a central position to align beneath the suspended cabin. Once lifted, the cabin was suspended above the chassis and its position fine-tuned. The engine bay had to clear the gear stick and transfer case selector levers, and the floor cutouts had to align with the mounts. To facilitate this, the gear selector and shift levers were temporarily repositioned or removed. Rust and old paint layers on the main steering shaft were tackled using an angle grinder fitted with a stripping disc. The second phase involved the cleaning and partial refinishing of the steering wheel itself before installing it. Proper alignment of the drag link and steering arms was checked to prevent bump steer and ensure responsive feedback. And now we can observe an old brake linkage arm being cleaned with a wire wheel attached to an angle grinder. This process removes rust, grime, and any residual paint, ensuring the metal is ready for inspection or direct refinishing. The artisan uses wrenches to secure each pivot and fastener, aligning linkages with the original mounting holes. This assembly connects to the cable-based handbrake system and main brake rods. The rods and cables must be tensioned evenly to ensure symmetrical brake performance between the left and right wheels. Thus, each pedal was paired with its return spring, which ensures that the pedal reverts to its resting position after actuation. Proper lubrication of the differentials, axles, and transfer case is key to ensuring long-term durability, reducing wear under load. Then, the double bolt system adds robustness to support modern high-output alternators. As we see, the restorer must have a huge knowledge of how mechanics used to work. This model, a rugged military vehicle produced in post-war France, embodies a design ethos very different from today's vehicles. Derived from the earlier Renault Golette platform but adapted for four-wheel drive under the model R2087. It served widely with the French Army, police forces, fire brigades, and rural industries. As a result, most surviving examples were subjected to decades of harsh service, leaving them mechanically and structurally tired. Unlike more famous vintage vehicles with strong restoration supply chains, the R2087 lacks a dedicated commercial parts ecosystem. Very few aftermarket parts exist, and those that do are often sourced from donor vehicles or small vintage supplier circles in Europe. The project thus demands fabricating most structural and mechanical replacements by hand. This makes every repair an exercise in reverse engineering and craftsmanship rather than a simple replacement. However, the vehicle was designed and built using mid-century manufacturing standards, simple but durable. Riveted panels, bolt-on frames, cast iron housings, and rudimentary electrical systems reflect a time when serviceability was prioritized over comfort or modularity. In this sense, the lack of modularity means that components are not designed to be removed or replaced in isolation. Disassembling one element often requires partial or complete disassembly of adjacent systems. For instance, removing the pedal assembly or steering column might involve detaching other sections of the dashboard supports. This nested construction style slows progress and requires detailed photographic documentation. Also, it is paramount to label during disassembly just to guarantee that it can be reassembled at all. Then comes the issue of fasteners and seals. In modern vehicles, bolts are treated with anti-seize coatings or are designed for easy, torque-specific removal. Components like the differential, brake backplates, or suspension bushings may vary slightly even within the same production year. Therefore, even when a similar part is sourced from another donor vehicle, it must often be modified or adjusted by hand. Finally, the absence of comprehensive factory service manuals for restorers means much of the process involves forensic mechanics. This includes decoding old service bulletins, comparing parts from other vehicles of the era. Even when manuals exist, they're often vague, intended for trained military mechanics or factory service departments. These documents were originally written not for civilian mechanics, but for factory-trained technicians or seasoned military personnel. All these individuals are already deeply familiar with the design language, mechanical conventions, and wartime improvisation techniques. With all this solved, the Renault R2087 is near completion. Since the vehicle's original flatbed or cargo enclosure had either been removed or extensively modified through years of heavy use, the restorer opted for a fully custom fabricated solution. This entailed not only architectural planning for structural integrity and alignment with the chassis, it also involved precision welding and fitting of the frame using square steel tubing. The rear wheels chosen for the restored Golette were aggressive off-road tires mounted on robust steel rims. With the chassis raised and leaf spring suspension restored to optimal flexibility, the wheels now sit higher within the wheel wells. Each fender was formed from sheet metal, shaped with mallets, dollies, and a shrinking stretcher tool. This allowed the restorer to match the curvature of the wheel arch and maintain symmetry between the left and right sides. Since the tire dimensions were larger than standard, the fenders had to be extended outwards and flared slightly. Their mounts were welded to the cargo frame's side beams and bolted through reinforced brackets. Because the flatbed was built from scratch, it offered the rare advantage of being designed with its integration in mind from the start. The steel panels forming the outer box of the cargo bed had to be fabricated and welded to the existing square tube framework. These panels, typically 2 to 3 millimeters thick, serve both a structural and aesthetic function. To minimize corrosion between the joints and over welds, all seams were later sealed with anti-corrosion primers. It signals that the truck is no longer just a relic or a mechanical showcase, but, once again, a tool, ready for real-world use. Then, the rear drawer system adds an innovative, practical dimension to the cargo bed. Custom-built using fabricated steel rails and guides, it functions as a seamlessly integrated deployable storage compartment. The choice to weld reinforcing channels to the frame ensured that the drawer could carry significant weight without jamming. Smooth sliding action was achieved using industrial drawer slides or rollers. Also, stops and locking pins were added to prevent accidental deployment while the vehicle is in motion. And so, with the tires back on the road and the engine breathing once more, the Renault R2087 is ready for new terrain.